Recording. This training will be recorded, so you all will be getting this after the training. Next slide, please, Jennifer.
Okay, yes, there we go. There we go.
All right, well, welcome. Thank you for tuning in. My name's Ital Torres, and I'm with the 3C Run team. Today, we have carbon reduction through electrification, part 2, heat pumps for our all-electric design and construction series with Jennifer Rennick and Grant Murphy from Imbalance Green Consulting. They'll tell you a little bit more about who they are and what they're teaching in a bit, but before that, I just have some housekeeping slides and a little bit of an introduction about 3C Run for folks who are new to our network. Next slide, please. I'm sure by now all of you are super familiar with Zoom, but we ask that everybody make sure they are on mute throughout the duration of the course. And if you would like to verbally participate, please raise your hand in the participant section and we will call on you to mute yourself. We encourage you to participate and ask questions through the chat box. Next slide, please. A little bit about who we are. We are the Tri-County Regional Energy Network, which is a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working on improving energy efficiency in our region by offering free programs and services for building professionals and households. 3C Run is funded by ratepayer dollars, which are collected through the public's good charge found in our utility bills. Next slide, please. We currently have 3 programs. The first one being our Energy Code Connect program, where we offer industry trainings, regional forums, and Title 24 consultation services called the Energy Code Coach to help building professionals navigate the California Energy Code and green building requirements. The phone number is listed on the slide. And you could get in touch with our Energy Code Coach hotline. And we also have an inquiry form on our website that I will drop the link to a little bit later. We also have our building performance training program, which we offer trainings on technical and soft skills related to building science principles and systems for high performance building. And our last program is our home energy savings program, which serves households that are historically underserved with free and discounted home energy upgrades. And with that, I'll hand it over to Jennifer and Grant to get us started with our training today. Thank you so much.
Sitzel. Hi, everyone. I'm Jennifer Rennick, and I'm here with Grant Murphy. We're both, part of the 3C Ren group and also Imbalance Green Consulting. I'm a licensed architect and certified energy analyst, and Grant is also certified energy analyst, and he probably has, you have a few other things now after your name. Grant, are you going to chime in and tell us?
Yeah, I have some of the passive house stuff. Done work in that world for a little while now.
That's great. And commissioning.
Yes, I've been doing commissioning for a little while too.
So today, let's see, in the chat, let us know if you're like designer, architect side of things, or if you're coming here as a plans examiner, trades interested person. Feel free to put that in the chat and just let us know a little bit about who we're talking to. And this 5-part series, this is part 2. It is part of the AIA California ZNCD, so Zero Net Carbon Design kind of learning package, so to speak. And you, if you need those credits for your license exam, these classes will help qualify for that. So today we're on part 2, heat pumps for space heating and cooling. And then next time we do it, we'll drill down a little bit more on heat pumps for domestic hot water and other ways to heat hot water. And then part 4 will go in deeper to ventilation and heat recovery or energy recovery ventilation systems. And then the last class will drill down more on appliances and energy storage as part of the whole package for an all-electric or nearly all-electric home and building. And if you can't make it on one of the classes that we're doing via Zoom, then we will also be in person in San Luis Obispo in October and November. And we'll just take all 5 classes and divide it into those 2 days. So we hope to see you there if you can't make it on our next class. These classes do qualify for AIA learning units, and you'll get a copy of the slides later on after we're done with the course. Today, we're going to do a quick review of the ZNCD buildings and California's clean energy goals. The first class, we went over that quite a bit and talked about a clean electric grid. And today we're going to kind of review a little bit about that as we segue into heat pumps for space conditioning. And then in that sort of big picture, we're going to review some of the types that use the function and distribution as we drill down in sort of system size, and also take a closer look at heat pumps. We're going to look at a little bit through the lens of the consumer, but also for the architects to kind of understand what it is that your clients and what you might be seeing out there, especially if you're trying to learn more about heat pumps, specifically mini splits. And then we'll review some tips for managing client expectations about those appliances, and some tips for Title 24 for residential occupancies that specifically address Title 24 for right sizing, some HERS measures, and the variable capacity heat pump credit that you can take under the performance method of Title 24 for your residential projects. All right, so just as a kind of background, so ZNCD and zero net carbon design for buildings and California's clean energy goals. A lot of buildings, not just in California, but a lot of buildings in our country now are looking to going all electric, and they're using heat pump technology for the space heating, the water heating, a lot of the appliances, along with producing electricity on site and looking at using reduced carbon building materials in the first place. And all that ties in with what California is doing for having an all-electric buildings, or nearly all electric where possible, so that California reduces its overall carbon footprint. And so part of that is to have an electric grid that's expanded and stable. And it needs to be expanded because we're looking at having our transportation be zero emission. A lot of our transportation, our cars are going to be all electric, and our buildings are going to necessarily need to be essentially, as Andy put it last time, gas stations for everybody that comes to our buildings, and that they can plug in and charge their vehicles if needed. And we're going to have a grid, an electric grid that is continuing to build out its solar and its wind power and battery storage. So California has been on this pathway to carbon neutrality for years now. And just as a reminder, every 3 years, California has a new Title 24 code update. And the Title 24, in this sense, what I'm talking about is the energy code. And a lot of times, Cal Green and part of the residential code, and then there's a greater agreement with the mechanical and plumbing code, all to support California's move towards clean energy and a zero net carbon future. So the idea being by 2045 or sooner, will have 100% carbon-free electric generation, and our buildings will largely be powered by that clean energy grid and or by the electricity or wind power that's being produced on site. So just a reminder, we're currently under the 2022 Energy Code, and this energy code specifically was looking to encourage heat pump technology for space and water heating, establish electric ready requirements for our single family homes, expand our PV systems and battery storage standards, especially now for the non-residential buildings, and strengthen our indoor air quality ventilation standards. And the reason for that is homes and businesses use nearly 70% of California's electricity and are responsible for a quarter of California's greenhouse gas emissions. So as architects, designers, planners, we can have a big impact on that. So when it comes to all electric or nearly all electric buildings, new construction is fairly straightforward in that we have the technology and the equipment to build our new buildings to be largely all electric. And there are some instances for really large scale buildings and industrial applications where right now going all electric with the existing technology might not be that feasible, but California and the rest of the country is working on hydrogen and other sources of energy to be able to do that. And the existing building stock, which we have a lot of in California, there's incremental opportunities to head towards an all-electric building by doing HVAC replacement, appliance replacements. You can add on-site solar and batteries, and you can continue to improve the building envelopes as buildings need to be maintained and upgraded. The other kind of approach for existing buildings is that, which is so it's a two-pronged thing, is that California is really looking at the infrastructure itself being decarbonized and coming up with other appliances and other ways just to reduce the natural gas carbon footprint of those existing buildings. So even if those existing buildings use perhaps more energy than new building stock, at least the energy those existing buildings are drawing on are coming from a clean grid. And this, there's Grant working on another commissioning agent on a project that we were working on that employed a lot of solar photovoltaics and electrical variable refrigerant flow heat pumps for the building space heating and space cooling needs. When we talk about ZNC or ZNCD buildings, zero net carbon buildings, really one way to look at it is a bit of a review for folks from the last class is first we're going to choose materials that have a low embodied carbon footprint. And then the thinking is we also are going to design very energy efficient buildings from the get-go, so they don't need as much operational energy. And then we supply those buildings with clean electric energy, whether it's on site with wind or micro hydro, solar, and at the same time, we decarbonize the entire electric grid by adding energy storage and other renewables to the electric grid. So we're less and less dependent on fossil fuels. And then within the building itself, we are going to use heat pumps, and we're going to be starting to use heat pumps with low global warming potential refrigerants. And those heat pumps are going to be used for our space conditioning, our water heating, and all of our appliances. And, you know, today we're gonna focus on the space conditioning aspect. But when it comes time to talking to your clients, what we found, or I found as a designer, an architect, but also what we find as consultants, is that we as a collective group talk about heat pumps for water heating, heat pumps for space, heat pumps, and we're finding most of the people we talk to don't really know what we mean by heat pumps. And so I put this slide in here to kind of as talking points for you as architects and designers to kind of remind yourself and remind folks that we have heat pumps all around us. We just usually call them air conditioners. So our typical air conditioner is a heat pump, albeit it might not be as efficient as the new heat pumps coming in the market, but it's still a heat pump. Heat pumps use the refrigeration cycle. So as such, our refrigerators, our personal refrigerators at home and the refrigerators in our supermarkets, those are all a form of heat pumps. And then all of the appliances you could think of were surrounded by heat pumps. Our air conditioners and now our heaters or heat pumps. Our electric vehicles use heat pumps in them to condition the air. Or a lot of pool heaters are now heat pumps. So one of the best energy efficient ways these days for heating your pool, for example, is to have a heat pump that is then powered by your solar panels. And we use heat pumps for heating water, both domestic and service hot water, and sometimes for industrial processes. But again, those really large might need to be still boilers, and we're considering hydrogen. But for talking to your clients, I mean, when you look around your house, you're probably surrounded by a number of heat pumps. And you can use that as a way to talk to your clients. Now, when it comes to heat pumps, and which are the air conditioners, we think of refrigerant cycle. We know that refrigerants have caused a lot of problems in terms of impact on climate warming. And a lot of you might remember a lot of talk with refrigerants and the ozone hole and ozone layer. As a result of that, we as a society started to pull back on those types of refrigerants. And as part of really a global effort to reduce our greenhouse gas emissions, specifically, we're looking at refrigerants and giving them what's called a global warming potential rating. And so we compare it to like the equivalent of carbon dioxide. And so carbon dioxide would have a global warming potential of 1, just to give you a scale of that. Most of our heat pump equipment in the space heating and cooling world that we're talking about today use what's called R410A refrigerant. And that has a global warming potential of 2088. Well, it's considered quite high. And under the AIM Act, which is the American Innovation and Manufacturing Act, we call for a phase out of refrigerants with a high global warming potential. And so under that act, the EPA set the limit at 700 GWP for our chillers, our air conditioners, and our heat pumps that are manufactured after January 2025. So that's coming up. It doesn't mean that that particular refrigerant will be gone. It just means that the new equipment that's manufactured after January 2025 will start using some alternative refrigerant. And there's 2 that are most likely being adopted by the manufacturers. And so you might hear about this, and ones are 454B which has a global warming potential of 466, and that is being adopted by a lot of manufacturers. And then you might hear folks talk about R32, and it has a higher global warming potential of 675. It's still under the R410A, but it's slightly flammable. And you might hear about that as a designer, like, oh, I don't want that refrigerant because it's flammable, and it's really only slightly flammable. And so the workaround on this is that the heat pump equipment, it's a three-prong approach. A lot of what we're looking at for heat pumps in the future are going to use smaller amounts of refrigerant and likely keep some of that refrigerant only outdoors and not run it through the building. The other is that they'll have some leak detection baked into the appliance itself, and then a mechanism to clear out that refrigerant if a leak is detected. So in other words, to mitigate the concern about that slight flammability. And then the other thing is there's a natural refrigerants, including R744, which is made from CO2. So it only has the global warming potential of 1. And it turns out that it's an excellent refrigerant for heating hot water. So it's in some of the heat pumps that are available on the market, and also being used for chilling and cooling. So Carrier now, for example, is one brand that's showing that they're on the path to sustainability. And so they have their new Quiet 2 CO2 Quiet Cool appliance that they're rolling out for retail and commercial applications of refrigeration. And Grant, anything you want to chime in on that section before we get into more of the heat pumps?
Yeah, did you include the chart of that flammability? Is that on the next slide?
No, I did not. It seemed like it was taking us off topic, but
Yeah,
maybe we should. Yeah.
I just wanted to note that slightly flammable, the rating system that they have to classify refrigerants from non-flammable to slightly to more. We have, like Jennifer said, deep in the weeds information about that classification system they put out, and it is barely more flammable. They do testing by igniting these refrigerants and test the flame propagation using, like how big of a flame it creates. And we're talking, this just barely exceeds that next classification tier. So it is one of those, when you hear it and they say it's flammable, it seems like it's a big change. The difference between that 410A and this 32 is incredibly small in reality. So that flammability component is often overstated with this change, especially when we consider we have natural gas and propane run in our homes, which when you compare it, these refrigerants and their flammability to those type of gases, it's not even close on that same scale. Those are highly flammable gases. So there is.
Good point. Yes.
Yeah, it is one of those things that when we talk about it, it comes across like, hey, this is flammable. Oh no, that we need to think about this. And the margin is actually really, really small.
Yes. And I just noticed there was a comment too in the chat section that, well, the refrigerants are only a problem when they leak. And so, yeah, I mean, that's true. And then the reality is our appliances, our, air conditioners, our heat pumps, they do leak. They're leaking a lot. And unfortunately, having talked to guys in the field who are doing this work, when there's changeouts, not everybody is, let's say, an honest broker of and following the rules, which means when they're done with the system, sometimes they're just releasing that refrigerant to the atmosphere and not actually capturing it again. And so appliances leak, people are releasing it to the atmosphere. So eventually, a lot of this does have a big impact on our greenhouse gas emissions. And that's why it's important that we continue to have refrigerants that will not impact our environment in the same way that some of the high global warming potential refrigerants are doing. Okay, now, just kind of when we talk heat pumps for space conditioning, a lot of times in our climate zone, we're talking about like split systems, like the ones in the picture. One of these units actually is a Sanco 2 uses CO2 and it's heating the hot water. The other unit, just happens to be a Fujitsu and it's doing the space heating. Both are split systems. There's an outdoor unit and an indoor unit. These are air sourced, but it's not the only type. It's just in our climate zone, a lot of times we refer to, and when we talk about heat pumps, we're talking about air source, but there's also ground source, sometimes called geothermal or water source heat pumps. And this is screen capture, some of the images that energy.gov uses to educate folks on heat pumps. And it's a real typical system that sometimes we'll see in our area and other states for sure, where it's a closed system. 4-inch diameter holes are drilled to 100 to 400 feet deep, and then a U-shaped pipe is grouted in place, and then that's connected to the rest of the heat pump system. And the heat is either absorbed in heating mode, is absorbed from the ground temperature, which can be a lot warmer in many cases than the outdoor temperature for winter. And then in summer, it can release that heat into the ground and help cool the building, especially when the outdoor temperatures are really warm and very humid. So an example of that we touched on last time was a mixed use project. And this case, they used both air source and ground source heat pumps, but the building itself used heat pumps throughout and had also been a good example of using less embodied carbon than a comparable concrete and steel building would have used. When it comes to the heat pumps we're going to talk about today, and given that we're on the Central Coast and these climate zones, we're mostly going to be focusing on air source heat pumps. So an example of this for like a larger scale building, Mitsubishi has this on their website. I think it's a great graphic that illustrates that you can have the outdoor air source heat pumps, large scale, and then those heat pumps can be connected to either ducted or ductless systems. They're variable capacity systems, variable refrigerant flow in that sense. And that means they allow for simultaneous heating and cooling. And the heat pumps can be up on the roof, and then the rest of the building can be conditioned through a variety of options for indoor units that are connected through refrigerant lines. And kind of the same idea, close up of the VRV system that was used on that senior living and hospitality picture that Grant was working on the commissioning on. And So it can be used for multi-story, senior living, hospitality, office, but also smaller scale heat pumps. They work the same way, but small scale, non-residential. They can be wall mounted, ground mounted, roof mounted. And then we also have the residential scale that a lot of us might be used to seeing that can be used both for multifamily and single family. When we look at these systems, as even those larger scale systems for the large commercial, almost all of them are made to have the ability to be a fully ducted system, or what's called a concealed ducted system, or sometimes pancake unit. So that would be the image up above that Daikin compressor, condenser. And then there's a variety of ductless systems that include wall mounted, two types of ceiling, recessed ceiling, floor mounted, and there's some other type of surface mounted ceiling units to choose from. And almost all the big manufacturers, they all are making all of these options. So it's really this kind of the way they look and what you think about on the inside of your project as a designer. You don't have to worry too much about the brand, but as a designer, you might be working with your mechanical engineer on what overall system you're going to use. And then when you get to the really like your small scale and residential, you might find yourself working with the homeowner or that tenant and really choosing with them what they want the look to be on the inside of the building. And then there's, of course, package systems, which we see for some of the multifamily and hospitality, which are also heat pumps, but they're just, mounted through the wall. And those are also come in a variety of styles. And some are more beautiful than others, let me put it that way. But today we're going to really kind of focus on these ducted systems and mostly the ductless systems. Overview, the big systems and the small scale systems, they're basically working the same way. When it's ducted, you're going to have a return duct system, and you're going to have a supply duct system. You're going to have your outdoor unit that a lot of times air source. You're going to have electrical connection. This case for the small scale and residential, it's usually a 230 volt, 40 amp, sometimes only 15 amp, depends on the system. You're going to have the refrigerant line that connects the outdoor unit to your indoor air handler, and then you would have the air handler with your coils inside, and that's what would heat and cool the air and have your fan for your ducted system. On the ductless mini split systems, instead we're going to have an indoor unit. In this case, it's an indoor wall mounted head that I've illustrated. You're going to have what's called a line set, and it's usually insulated copper with refrigerant tubing. You're going to have your outdoor unit. It's referred to oftentimes as the compressor or the condenser. The insulated copper refrigerant tubing connects that indoor unit to the outdoor unit. It also includes a condensate line or drain hose. Turns out that when you have that indoor unit in cooling mode, it condenses water out of the air, and that condensate needs to go somewhere. So kind of from a designer perspective, just keep that in mind, because a lot of times as designers, we might want to put some of these units on interior walls. That's okay. You would have to make sure there's a clear path to get that condensate either out of the building or into an appropriate drainage, water drainage. And then kind of to demystify this, I wanted to just show you a diagram of what is basically inside one of these outdoor units. And for clarity, I didn't show the onboard electronics, but these are the main kind of parts that you see on one of these. And they all have a compressor that's needed for compressing the refrigerant. And they all are going to have some type of four-way valve or reversing valve that allows the refrigerant to flow one way in cooling mode and the other way in heating mode. They're all going to have this outdoor coil. And the coil is finely finned copper usually piping that gives a lot of surface area to that refrigerant. So when the fan operates, the air is blowing through that coil and either cooling or heating the refrigerant. And then really what makes these appliances so energy efficient now is there's a metering device, and it's not just any type of expansion valve, but it's an electronically controlled expansion valve that can oscillate the refrigerant or oscillate on and off or meter out the refrigerant very specifically to the heating and cooling needs. And that's how we get these high efficiencies in the new heat pumps. When you talk to your clients about these things, maybe it's important to realize that this, in a way, the technology is not that new, it's just been refined. And so it works a lot like the refrigerator. So you've got your compressor in your refrigerator, you've got a condenser coil with a fan blowing, and it's usually at the bottom of the refrigerator. Some have them at the top, but at the bottom, you know that it's working because when you stand in front of your fridge, you might feel the warm air blowing on your feet. They all have a type of expansion or metering device, expansion valve for the refrigerant. And then the evaporator coil, which is in some refrigerator freezers, you can even see it on the back of the freezer or at the top of the freezer. And it's the part of your appliance that sometimes cakes up with ice, but that's essentially the evaporator coil. And that does the refrigerant flow process. So when it comes to how does that work with, say, a mini split, and again, the processes we're talking about in these mini splits are it's the same thing on the big, larger scale buildings as well. But there we have the compressor and reversing four-way valve on our outdoor unit, our condensing coil, and then we've got our metering device. Those three components are in the outdoor unit, and then our indoor unit has our kind of quote unquote evaporator coil. And then these are connected by the refrigerant, and it follows the refrigeration cycle that we all learned about in school. I'm assuming that we all took one physics class. Most of us are architects on the call, right? And, we can go more into this too, but I don't think it's, I think the main thing though, when you're talking to your clients is remind them they've got a refrigerator, and that's what's happening. But when it comes to like, how do you kind of design for these and what are you looking at? If your client decides they want a ducted distribution system, then we're going to look at where to locate the indoor air handler. Some of these can be located in the attic. A lot of times it's very convenient to either have a small mechanical room or a closet, so you can easily access the filters and do maintenance and checks on it. If you're going to have long duct runs, then you got to consider if you're going to build soffits or chases. And it's really the same kind of thinking you would if you were going to have a gas forced air unit. Only now you don't need to run gas to these units because it's all taken care of with the refrigerant from your heat pump split system. And then potentially you can swap out an existing furnace system with a heat pump. And I did have a project in a up in Oregon that's quite a bit colder than where we are here on the Central Coast. And they worked with a contractor who did just that. They were able to stay within the brand they already had and take out the old furnace and replace it with air handler and a new outdoor heat pump, and use the same ducts and keep the same fan and volume and static air pressure. Worked out really well for them. They were happy with it. There's also this concealed duct system. A lot of times we'll see this in our commercial projects, really common. So it's the air handler is there, the refrigerant line comes there, the condensate drain, you have to accommodate it. It needs to drain just like all the other units. And the ductwork is connected to this, and it operates like a regular ducted system. And then for our ductless distribution, these recess into the ceiling, like the picture on the left, or it could be wall mounted up high above the windows, like the picture on the right. They work in very cold climates, so getting down to -20 below zero. They have high efficiency, most of them. So there's a variety of ways you can work with this. And these two pictures are from a project that Carn Collaborative, Mike Horgan, who we work with, did on a couple of his projects. And so that just gives you a visual of what that wall-mounted unit might look like, and also the ceiling recessed unit. And I think one thing, if you get a chance to see them in person, it's useful to get an idea about that because of the scale or the size. And it depends a little bit on if your client is used to just seeing a small 6-inch by 12-inch duct register versus something that measures, 12 to 16 inches by 31 inches. Grant, before we jump on to the next section, that was kind of the overview. We're going to go into a closer look at the heat pumps, kind of from the consumer perspective. This is the whole section where I figure Grant's going to jump in.
Yeah, this is going to be the bulk of what we're hoping to talk about. This is kind of a deeper dive into what's available and the differences between units that are, that are commonly seen. Jennifer's going to talk some price points and kind of the deviations between, that Home Depot unit versus, what some might call a more premium unit, and what metrics or just different type of specifications are implied between those different price points of units. Our hope was just to familiarize people with what's available, and so often in the residential sector, these are just drawn in as, yeah, there's a unit here somewhere. And so just kind of arming all of us with a little more information that is applicable to making those decisions as early as possible, and making sure that the customer is getting what is ideal for their project and their budget.
Yeah, well said. Okay, kind of a different bend on this, or it's a different kind of big picture. We're all in the construction fields in the way, and we all are interfacing with companies that make these products that we want to use in our buildings. And so there is definitely a market we need to look at in terms of availability, and also giving us an idea of what are our clients seeing when they start to look around, go online, and start asking friends about these new heat pumps. Okay, so if you go online, you're going to find hundreds to choose from. Hundreds. There are so many. And they include full service HVAC installs to do-it-yourself kits and somewhere in between. And it can be overwhelming if you're just, even as a designer, if you're trying to get an idea about how to even talk to your clients for their small commercial residential projects, assuming that you don't have a mechanical engineer on board with this, or if you're just trying to go more to the specifics of doing the interior design work of a larger building. What are we really talking about? And also, I think it's kind of important to realize what this sort of big picture market looks like. And just for example, if we're going to talk about like the split system heat pumps, we went on to the HRI website to just start to pull some efficiency numbers, look at the products there. And so we had our intern working with us on this, and she identified 218 brands to look at. Just in that one category, right? And those are all the ones that are registered and available in North America. And then an interesting article, although this is from 2020, so it's a few years old already. The top 10 manufacturers of heat pumps and HVAC, they control 85% of the total North American market. Now, what makes it even a little bit more confusing for us as consumers, let's say you have a client who's like, oh, I only want something made in the United States. You could do it. It's a little tricky sometimes to kind of ferret that out, but also it's a little difficult to understand what brands to really choose from because, for example, Carrier brand has, or Carrier manufacturer, I mean, they have about 22 brands under the name Carrier that you might not realize is a Carrier product, for example. And Rheem has Rheem and Rudd. And Trane is also teamed up with Mitsubishi Electric. So you got Mitsubishi Electric, Trane products, and other ones. And then this marketplace is constantly shifting. So just when I thought I had kind of a handle to tell you this, just at the end of July, so I was reading in Reuters, and then I went to Bosch's website for their press release to get kind of the deal. And since Bosch is expecting the global market for heating and cooling of buildings to grow by 40% by 2030, driven because of this technological progress we've talked about, and the fight against climate change, and the new regulations dealing with global warming potential, et cetera, they decided that it would be a good call for them to acquire Johnson Controls and Hitachi's residential light commercial heating, ventilation, and air conditioning business. So now when you talk about Bosch, yeah, they're now going to be the big players. And they'll still have their Bosch brand. So now where do you even begin? Because there's going to be a big variety of brands and quality and price points. And part of this big goal for a lot of the manufacturers is to come up with a branding package that meets people's price point, appears to give people choice in the market, and they want a lot of these products to be very cost effective so that they're readily adopted. And the cynic in me also is seeing that there's getting to be more and more promotional deals as they're selling the R410A refrigerant products. Just and that's just part of the reality. But this just gives you an idea. At Home Depot, you've got a lot of brands to choose from. Lowe's, a lot of brands. Ferguson Supply House, Costco online is selling the Mr. Cool. I also noticed Ace online, Ace Hardware is selling the Mr. Cool brand. And then through your professional installers, you could still you could get the Mitsubishi, Fujitsu, Daikin, Samsung, like the high-end full build-out systems that you wouldn't necessarily see advertised that you could pick up from Home Depot or Lowe's or the local supply house.
And our goal isn't to go through each of these and learn all the different brands. We're just trying to show what's made the consumer market a little confusing. And a lot of the times when talking about these, it's availability. You know, it's access. A lot of homeowners now are just Googling their mini split systems and creating confusion amongst you know, between their contractors, the design team, and themselves. So we're just trying to show that this is the reason why that's happening. And when you back it to that market cap distribution, there's only a couple people actually making these units. So, you know, fundamentally, a lot of them are very similar units when it comes down to the components.
Yeah. And the reason Graham mentioned that is because we've had some folks who were like, oh, I got a good deal. I bought the whole system online already. And now my general contractor isn't really interested in installing it. What do I do? And so that's part of it. That's part of it. So, okay. So kind of give you an idea here of kits. Buying them as whole kits are common. And the professionals can buy them as kits and the layperson can buy them as kits. And when I say kits, it's like including the indoor unit, the outdoor unit, the refrigerant lines, the thermostat, and some of the parts and pieces, but not all of it. Sometimes you can buy additional kits that include the tape and putty for patching holes. And you can buy another little kit that includes surge protectors and the electrical disconnect. Bottom line is, though, all these products are supposed to be installed by a qualified professional, unless it's truly a DIY. But even then, you probably need professional help. Part of the reason these wall-mounted units are becoming so popular, and they really are the biggest thing that we're seeing out there is being sold, is because they're incredibly easy to install. I had this Fujitsu system installed in my house, and it took them a half an hour to get that indoor unit set up and ready. And the whole thing, outdoor, indoor, everything, running the refrigerant lines, took 3 guys, 3 hours. They were done before lunch. So they're very, very easy to install. Biggest kind of features that we're seeing that impact the purchase price is really the biggest one right now is this product engaged in a promotional pricing? There are a lot of sales and deals out there that it just seems like everybody's knocking the price off of these systems lately. So that's great. The other thing is that how quiet the indoor sound rating can really affect the price. Its efficiency, and if it's Energy Star, it qualifies for potentially for tax credits, either north or south part of the U.S. So you could have up to $2,000 tax credit. Also, some of the units are going to, if it's a professional install, then they possibly would qualify for California, the tech program, which would be an additional $1,000. So that kind of changes the price, because the tech program one, those products tend to be higher quality. And then the capacity, the higher a capacity, the higher the cost, and whether they have a cold temperature limit. The colder the unit can go usually adds more costs. And then the electrical connection, turns out that the 120 volt, 115 volt units, part of the DIY, those are more expensive than the 230, 240 volt. And then the refrigerant line itself, the longer the lengths, the costs go up. And then just to understand the whole package and what we saw specifically with the person that I'm thinking of that was quite excited that they bought their whole system online. It wasn't really clear to us that they understood that there was a lot more that goes to the full install. Depending on the brand, you may have the refrigerant lines that you would use to connect the indoor and the outdoor unit, but not all of them are insulated. Some of them just have like plastic coating on it. So you may need to be purchasing additional insulation. You may need, in a remodel case, to have exterior line set covers so that they're protected, or it just looks better. And you can have sheet metal made, paint it the color of the house, or you can buy prefabbed like vinyl exterior line set covers. And then you have to consider, how's that outdoor unit being mounted? Is it on ground pads, a rack that attaches to the building? Is it roof mounted? And then your thermostats, smart controls go into it. And then you can't forget the electrical work that may need to be done in order to get these things installed. And a lot of times a homeowner isn't really thinking about all of that when they get excited to just purchase one of those units off the website. So for example, I just ran through this for a single zone, 9,000 BTU. This is sold as a kit. I just picked the brand Pioneer because I saw it was available at Lowe's and Home Depot and online, and it's a popular one. And I saw pricing anywhere from 728 to 1,630, really, for the same thing. And then when you take a deeper look, it appears the same. Oh, sometimes the models are slightly different. So like a little bit more expensive one has the higher efficiency, and then it's Energy Star, so it could qualify for the potential tax credit. Makes a difference. This particular brand has a 5-year warranty standard, but you can extend it up to 7-year parts and 10-year compressor, but you have to work with a qualified installer and sign up for their warranty program. And when it comes to finishing the actual install, you're going to need to add between $1,200, $4,500, depending on what you choose, the line lengths, the complication of the install. And you need to include another $750 to $1,400 to run your electrical and have a new electrical disconnect and potentially some work on your panel. So the package, the price you see online might be one thing, and then the actual install could more than double what you see online. So I think that's kind of useful information to help your clients understand what they're looking at.
And as Jennifer runs through these examples of, a low price unit all the way going up to a high price unit, these are all a 1-to-1 single outdoor unit, single indoor unit. We were just trying to set a baseline of sorts. Of course, adding additional indoor units drives the cost of the system up and all those installation costs up. And then it also increases, in most cases, the capacity required of that outdoor unit, also increasing. So this is kind of the single zone, single room, most commonly used in a retrofit, just to try to give us a baseline playing field when comparing all these different specification and components.
Mm-hmm. Yeah, that's right. And then this particular brand seemingly is a little tricky to tell the difference between one price, the other price, if you're trying to shop online. And there were units that have the outdoor units, almost all are variable speed inverter units, but then the indoor unit, you could have a 3-speed or a 4-speed, depending on kind of the level of fanciness, I guess, and then the price goes up with it. And also whether or not these things are rated to be below 0 in cold temperatures. So in this case, there were like 3 options to choose from, but it's not always obvious when you're just clicking around online. But in most cases, for our climate zones, we're not necessarily needing many splits that can operate at negative 13 degrees Fahrenheit or negative 22 degrees Fahrenheit. And then most of these things, your style and the color, it's white, it's white. And you'll find that a lot of them look really similar. Like this one has a special feature where it's got a little digital readout on the lid that tells you the temperature and reminds you if the filter needs to be changed. And you'll notice that other units look just like that. And when you dig in deeper, you find out that, oh, that shell's made by the same company, essentially, and then shipped around to the other brands. So this would be an example of kind of your budget brand, budget builder friendly brand. Nothing fancy, but seems to work. And then we move on from there. And then, interestingly enough, if you get a true do-it-yourself kit, it actually costs a little more. And the other kit that required a professional install, so you have to factor that in. But the true do-it-yourself kits, they pride themselves on having their Novak Quick Connect, from the Mr. Cool brand. And the refrigerant lines come pre-charged. It doesn't take any special skill, really, supposedly no special skill to connect it up. You have to be careful because they are, I had some of the guys who are in the field say that they have gone back out and fixed some of these because folks didn't quite connect them properly. So you have to be a little careful. You'd want to make sure all that is done properly. And depending on your skill set, you may need to hire a professional to help you, or you're recommended to hire a professional electrician to get the electrical set up. I watched a few blogs for the fun of it, and some people video their installs because they were so excited about how great these are. And then, yeah, let's just say there were a lot of comments by professionals who were like, yeah, dude, you didn't do the electric right. You really should call a professional to come out and help you. And so I'm just putting that out there as you talk to your homeowner clients. A lot of these are a little more expensive because the electrical is 115 volt, 120 volt. And they do qualify for the Energy Star tax credit in the southern region. And then they have these special features like a follow me function. They're Wi-Fi enabled, and you could get them with leak detection. And then because they're really trying to have a market in mild climate areas, you make sure that if you do go this route, that you get the unit that touts that it comes with a corrosion resistant coating for the coastal climates. And I think they call it their gold fin treatment. And these come in white, but warranty, that's like a really big thing on the pricing too. The warranty, it's just the 2-year parts and 1 year compressor. So the idea on some of these units is that you could do it yourself. You save some money that way. You pay a little more money up front for the whole kit, but it's temporary, it's budget, and they're not going to give you a really big warranty on that, especially because you're going to install it yourself. So that's kind of a big difference on these. And the efficiency is up there, it's high. The sound rating is good. You know, they come with 4 speeds, variable inverter compressor on the outdoor unit, 5-degree Fahrenheit. It's, you know, it's good. But just as a note, Mr. Cole also does make their HVAC Pro line of products, and they clearly state that those need to be installed by an authorized technician and not intended for amateur installations. And the price on those drops down. It's comparable to the first product we looked at. And then kind of that big, you know, kind of big jump. There's the budget builds, there's the do-it-yourself, and then there's the built-up system. And these are the ones where you're gonna hire a professional to install them. Like Mitsubishi, for example, they would prefer their products are installed by their Mitsubishi Diamond contractors. And if you do that, that warranty is going to boost up to 12 years for the parts and 12 years for the compressor, if that product is registered under the warranty program and installed by that professional Diamond contractor. The price goes up. It's, you know, these are like $1,600 to $1,950 just for what you're looking at on the screen, those 3 parts. And then since the installation's not included, you're going to add anywhere between, you know, $3,500 and $5,000 just for the equipment install and all the parts and pieces that need to go with it, and another $1,000 to $1,400 for your electrical. And these are available through your contractor, through the professional installing contractor. And they need a professional because these refrigerant lines have to be evacuated. They're vacuumed out, and brazed flare connections. And we'll see in the slide coming up with the HERS, you do need a HERS technician to come out there, and they're supposed to be, the refrigerant is supposed to be observed and see that was properly charged. Same thing for those lower cost units as well. But it's a little sketchy. I hear from guys from our building department that not everyone's actually asking for any of those inspections or HERS raters to come out and do that. So this unit, they offer, so some of their special features. So they have an anti-corrosion treatment on the coils. They've got this dual barrier coating on the interiors, which keeps everything clean on the interior coils. They have their whisper quiet mode, which gets down to 19 decibels. And then even their standard warranty is 7-year parts and 10-year compressor. Very high efficiency. They have, 5-speed on the fan, indoor fan, because of that whisper quiet mode is the very lowest. Their cold temperature range is 5 degrees Fahrenheit. So perfect, for our climate zone, that's fine. They don't have any sizing guide estimate. It's not applicable because these are supposed to be looked at, sized, and put together properly by a professional. But Mitsubishi, it's a little higher end, so you can look at like designer colors. They've got black, gray, and white and slim styles available. And so you would go online with your clients, and if you want something that looks just a little more higher end, you might end up going with this brand, for example. Now, just to kind of give you a rough idea, like if you're going to compare like cost of the ceiling recess versus the wall mount, for example, and this is on the Mr. Cool do-it-yourself example. And really the key price difference I found on all this is this particular product involved in a promotional pricing plan? And if the answer is yes, then you're going to have a lot of cost savings. If the answer is no, then going with, for example, a 2 wall mount unit, versus a 2 ceiling recessed unit, and then the capacity on these is both like it's 18,000. Same refrigerant line lengths on both these units. Really, the price difference on these is the fact that they took about $1,000 off on each of those wall-mounted indoor units, because these are the ones they're promoting right now. So just the equipment itself comes out almost half of the ceiling recessed, but you go to a different brand and a different it's not part of the promotional pricing, and then these systems are really pretty comparable. So your client then is only looking at the difference of maybe labor costs or ease of installation, and that might be worth it. Especially we have clients who just do not want something mounted on their walls, but they're perfectly happy with having something in the recessed in the ceiling. And then from the design side of it, it's like just kind of understanding where these are going to go, because you do need to pay attention to the condensate line, that drainage path on all these systems. Now, if we take a look at like the Mitsubishi, and just the real rough cost comparison of, say, you go with like a 3-zone ductless versus a ducted, and we're just looking at the core components themselves, the pricing is pretty comparable. And so the real big difference on this is whether or not you're going to be able to install the ducts easily and compactly, or maybe you need this ducted system because you need to cover more zones than just 3, which adds to the expense. But then if you need more zones on your ductless system, then that price goes up, and it's going to go up sometimes quicker than the ducted system. It really depends on the project. And so this is, again, for something like this, just kind of give you idea, the equipment pricing is pretty comparable. It's really all about the install and the design itself. And then, some of your clients might wonder, what's the difference between your P series and your M series? And the M series tends to be a little more like the residential, P series light commercial, and higher, bigger residential. The P series unit's a little taller, bigger. And kind of the big question on this is just, how do you want to deal with the zoning on it? We've had a client who currently wants ducted system no matter what. They have a central location for that thermostat. And, when you go to these ductless systems, every indoor unit has its own thermostat. So like in my own house, I have a 3-zone system. And so I've got 3 thermostats, and everyone, my kids, by everyone, I mean my teenagers, they're like, Mom, this, and they're like messing around with the thermostats in each of their zones in the main house zone. So, that's just something to understand how it works. Part of that is you want to set your thermostat and leave it typically. And then the system works really well. That kind of segues into the next section for managing some of those client expectations and our Title 24 residential occupants. Before we kind of go into that next section, Grant, is there anything you want to add or comment on?
We kind of jumped over it. The refrigerant lines between those different options, the DIY kits, the lower tier systems or the upper tier systems. When you get into those budget systems, they're pre-charged with a line length, and that line length is the distance you can route between that outdoor unit and that indoor unit. That's typically fixed. Whereas when you get into these higher end units with professional install, there's more flexibility in that, and you charge the system and the line itself. That typically shows up as the cleanliness aesthetics of the install. I'm sure everyone has seen the white plastic on the outside of homes and retrofits that are coiled or wrapped, and that's a component of those refrigerant lines. How it's installed can be detrimental to the system's performance, life of the performance, because if you have someone, an amateur installing it, there are considerations. You know, you're pumping a fluid, so it's not as simple as everyone might think. And it often ends up being ugly installs because you have this additional length of line that you just have to put somewhere. When you have a professionally installed where they're running the line and pro pressing or brazing the refrigerant line itself, you can have a much higher quality install that looks better, is hidden, etc.
Yeah, that's that's actually a perfect segue, because that part of that managing the client expectations, I mean, that top bullet point is, what do you do with that sort of line set length, and they typically come like 16 feet, 25 feet, 30 feet, 50 feet. And like some of those examples we ran through, like the 2-head indoor unit, 2 ceiling recessed unit, I chose them both as like a 16 line length and a 25 line length, assuming one unit's further away from the outdoor condensing unit than the other. And with those kits, when you really dig into it, the manufacturer really recommends that you coil any extra line length horizontally in the attic, as opposed to coiling it outdoors somewhere. But that doesn't always happen, as Grant alluded to. And then the other big thing is they'll say avoid coiling, or don't coil that line length vertically. You need to do it horizontally. So I've heard stories of someone who's professional comes out there, looks at the system, sees why it's not operating so well, and then they basically take that extra line length and figure out a way to coil it horizontally. And I've heard of cases where sometimes they're able to rig up something so that it's let's say the unit is wall mounted, they can coil it horizontally under the unit and then allow it to go up into the space. So, probably as architects, unless you're doing this on your own project, you might not run into this so much, other than being aware of these things, that if your homeowner went ahead and bought the kit anyway and then really wants to use it, and then they find the contractor is happy to install it for them, this would be something to manage their expectation. Just know that that extra line length needs to be horizontal. The other thing from an architect's perspective is that outdoor unit, you want to make sure that the location that is designated for the outdoor condensing unit is at least 5 feet away from dryer vents. And that's actually a code requirement, but it's very practical, because the fine fins on these coils on that outdoor unit can clog up with dryer lint very easily and ruin the efficiency.
Yeah, keeping
Also,
those units clean is a big deal, and you know, hiding it with a bush is not always the optimal design decision, because then you're just bringing in, you know, plant and dirt, and once that unit gets dirty and clogged up, you're asking for maintenance issues and reducing the life of the unit.
yeah, that's right. And then
Yeah.
there's the owner maintenance on the indoor units. So some of these manufacturers are recommending you clean those filters every 2 weeks, depending on how dusty the person's house is, depending on what environment they live in. So some of them come with a LED reminder on the front cover to clean them. Others, you know, they just expect you to go in there and clean them once in a while, like once a month or at least every couple months. Um, that owner expectation of set the thermostat and leave it. So one of the biggest things I hear from one of the installers that we've worked with, uh, one of the biggest callbacks he gets is, and I know people who are even in the profession that we're in have done this because they think of it as like their old school furnace or their old school AC that was oversized. And so they turn everything off at night and then they turn it back on first thing in the morning, and they expect it to heat up quickly like their old furnace did. And maybe they go to work and they turn it off because why should they heat their house when they're not there? But these heat pumps with the inverter technology, they do not work that way. You will be very dissatisfied and your clients will be very unhappy with the whole thing if they treat the system like an old school oversized furnace and air conditioner. So these are supposed to be right sized. You're supposed to set the thermostat and leave it and let it do its automatic controls for dialing down the refrigerant and dialing it up as it needs based on the temperature and based on the fan speed you may set on these systems. So you just set it and you leave it. And then there needs to be some professional maintenance on these. And so a once a year checkup by a professional is recommended. And when it comes to this owner maintenance, really, they should clean the filters regularly. So if you take a look under the hood of a wall-mounted one, for example, the one on the left, upper right, I mean upper left corner, you can see that they're all those things are starting to get clogged up with dust and lint. And sad to say, this is from my own house. When I first got it, I didn't realize how much dust I had in my house. And so it didn't take long before those filters were really clogged up. And since I've had the system now for 6 years, I haven't actually had as much of a dust issue in the sense of just leaving all my doors and windows open 24/7 because I used to not have air conditioning at all. And that's how I used to do it. So now my house isn't as dusty and I have, you know, air conditioning because of the heat pump. But these things are easy to clean. The wall mount ones, they're easy to remove. They can be cleaned with a light vacuuming and you can rinse them with water. And if you keep them clean, you have excellent performance. And then some of the brands like Mitsubishi, for example, and there's some others that offer like lots of accessories, including like allergy enzyme filters and PM 2.5 micro filters that you can add to these. So there's a lot to know. The other thing, when we talk about this for right sizing the system, you know, especially your new construction, this is going to be happening, or it should be happening. The residential remodels, retrofits, that sometimes is a little tricky, and a lot of folks are still using rules of thumb for sizing these systems. But new construction, a lot of us on this call are designers and architects. We're going to be engaged with our Title 24 energy calculations, but we also should be including the ACA manual J load analysis or an ASHRAE load analysis. For our ducted systems, a lot of times your plans examiner is going to ask you for your duct calcs anyway, but even with the ductless systems, with your Title 24, if they're running it through EnergySoft software, for example, you can calculate a load on the HVAC summary sheet and just take a look that you're kind of right sizing these systems. Most of those rules of thumb are just going to be based on square footage and, you know, the size their unit has. And then a lot of those manufacturers' resources, even if you're a professional, like the Mitsubishi, for example, they have their professionals diamond tool that is used for making sure that all the system components are compatible with each other, because they have so many options on the indoor units and the outdoor units and all the accessories. So they help you make sure everything's compatible, but they expect the professional to engage with like right sizing. And Grant, do you have anything to add on this stuff?
No, just that that right sizing, the rule of thumb, the reason why doing an actual load calc is more beneficial is because the rule of thumb based on floor area doesn't include a specific climate zone or your building's conditions. So we're talking the quality of your windows, walls, roof, etc. And you're
Yeah, yeah. And I saw a comment in the chat about, you know, they have a new zone heat pump and they turn it on in the morning, takes out the chill, they turn it off, don't waste any energy.
yeah. Let's keep going, and we'll address
Yeah.
Arthur's question either in the chat
Okay.
or right at the end, so we can wrap up the
Okay.
content here.
Yeah. Okay. So FYI, when you're doing your Title 24 performance calculations for a new build residential, there is a compliance option that's specific to variable capacity heat pumps, and you can take performance credit for it. And it requires that these indoor units truly be indoors and that they're inside a continuous air and thermal boundary, and that these units are right sized, and the HERS rater will come out and confirm that the installed units meet your Title 24 capacity and efficiencies. And you need to have an indoor unit in each bedroom and the living area at a minimum. And this is true for both your ceiling recessed style units, and it can be done, and you know, depending on if you're doing a vented attic or non-vented attic or unvented attic, you would design your details and call out the system that it is inside the air boundary, which could be taped and sealed drywall as your air barrier or your air boundary. And here's some details for you to take a look at that you could include on your plans if your client goes this route and you know that your energy consultant is taking that variable capacity heat pump credit. Also part of these HERS measures is that refrigerant charge verification. And again, this is a very straightforward but required measure. And if your builder can coordinate with the installing contractor so that the HERS rater is there while that installing contractor is doing this work that they've been licensed to do with the refrigerant, then they can kind of take care of it all at once. And so it's straightforward. So then this is the last sort of takeaway for the architects and the designers is what we're finding is that we recommend that you list kind of these HERS measures, and especially note these HERS items on the cover sheet, because we're seeing that the plans examiners, but mostly the installing or general contractor is sometimes missing that these will be required as part of your occupancy permit So we suggest you put them on the front cover of your plans and just kind of call it out right away that your energy consultant had taken these credits, and these credits are needed to have this building comply with Title 24. And with that, I'm going to turn it back to Itzel for closing, and we'll take questions if we have a few more minutes, and if Itzel's willing to stay on the line. Otherwise, I don't want to keep you any longer, and I appreciate you all being here.
Yeah, thank you, Jennifer and Grant. No worries. I'll try to make this super quick so we could get to questions. But just some closing remarks. If any of you have any questions regarding AIA or ICC learning units, I'll drop my email on the chat. Please send me an email. If you need a certificate for this training and specifically, just email me and we could arrange that. If not, everybody should get their certificate at the end of the series. Coming to you in your inbox will be the slides and the recording and an additional survey, so be on the lookout for that. And then upcoming courses that we have, just wanted to highlight that our third part for the series will be on August 29th. So I'll drop the calendar under chat as well. And then next slide. Just very quickly, just wanted to highlight our Code Coach service again. If you have any questions regarding Title 24, please go onto our website or give that number a call, and they will answer all your questions. And I'll make sure to drop the link to the form on the chat as well. And with that, I'll hand it back to you, Jennifer and Grant, to answer some questions. Thanks.
Thanks, Itzel.
Thank you.
Please, anyone shoot in any questions. We'll stay on as long as people are engaging and want to have anything answered. I'll just touch on what I said to Arthur. Arthur mentioned that he's been operating his heat pump like a furnace, turning it off, turning it on as needed. If that works, that's great. In general, these systems don't produce the same amount of heat, like at a moment in time as our gas furnaces. They do a better job of sipping energy, just slowly maintaining a set point. And that's what makes them so efficient. So the conversation we're having with a lot of people that are used to having a furnace and now are having heat pumps put in their homes is that expectation. So I always tell people the old rule of thumb was, have a 7-day programmable thermostat with a setback at night or when you're not at your home, 10 degrees, turning the system off entirely. That was really common for your furnace because it turns on, heats excessively, then turns off when that's been met, and it's this large spike use pattern. These heat pumps were looking for a much thinner sine wave that follows that set point. So you can still absolutely, and you should, have setbacks for those systems. They're just a smaller setback. We're talking, 3 to 5 degrees. So yes, it will use less energy, but you won't, upon arriving back at your house or needing it to cool or heat, have this longer lag time to get it up to a comfort condition. And then of course that is dependent on the individual's, what they're comfortable with. Some people might be totally happy to have it be a little too cold for a little while or a little too hot for a little while and allow that system to catch up. It's that instantaneous gas heat that we're used to that's changed.
And to add to that, a lot of it depends too on the quality of construction of your home and the age of it. So a new build, if the builder did an excellent job of making the home tight and it's well insulated, I mean, you may not even notice if you turn it on or if you left it, because maybe your system would retain, let's say, the heat already. Even if you go to work, it might be retaining that heat anyway. And so maybe your system isn't turning on a lot anyway.
Yeah.
In my house is older. It's, I can definitely tell you it doesn't work to just turn it on and turn it off. And it is sized just to meet those loads efficiently. And so in the shoulder months, it's fine. The middle of winter, no. If I were to just turn it off, it wouldn't be able to recover quickly enough in the winter up in Atascadero to make my house feel comfortable. So we just set it back a few degrees, and that's what works for us. So it really, like Grant says, it depends. But up in Atascadero, specifically, I'm thinking of a client, similar age house, similar size house. They turned it off, and their wife was super unhappy, and the husband was like, no, of course we got to turn it off. And then they had the installing contractor come back out, troubleshoot the whole thing, talk to them some more, ask them questions, and then said, you know what, I think you just need to compromise here. Like, you don't want to turn it off, just set it back 5 degrees, set up your timer, set up your occupancy schedule, because you can schedule it, because Tascadero winters are they're cold.
Yeah.
You don't want to just turn it off.
It's a very common complaint and a change in how we operate these systems for existing homes that have retrofitted, taken their gas furnace,
Yeah,
put in one of those ducted units. That's kind of what we're trying to educate and dispel here. New construction, it's good new construction. It's less of a concern, and we don't hear a lot of complaints associated with that.
yeah, exactly.
If anyone has questions, please send it in. The next classes are going to be similarly formatted. We're still going to focus on the units available. This one was for the mini splits. There really is uh, very similar one type of unit out there. The water heaters, there's going to be a little more diversity in what units are available and the different types of them. Similar with the HRVs and indoor air quality. So we'll be able to show more specific equipment that might be interesting to people. But that the focus will still be just showing you guys what is available in the market that you can include in your designs or show to clients.
Yeah, that's right. Okay, if we don't have any more questions in the chat, or if anyone unmutes and has a question, I think we should let folks go and get on with their day. And I really appreciate you all being here. And I want to thank Grant and Itzel for this. And we look forward to you all coming to either one of the in-person sessions or to the next course in the series.
So much,
Great.
everyone. Have a great day.
See you, everyone.
Bye.
Bye.